Now let's actually perform some threat hunting. So I have detonated a sample of malware on our victim machine, and it is reporting into the Elastic Stack. So let's go ahead and use the security app to actually figure out some more information about it and actually find the malware hiding on the box. Additionally, to locate its persistence mechanism and its defensive evasions. So let's click on the hamburger menu and go down to under the security app detections. From here, I can see that I have a malware detection alert. And I'm going to go down to the very bottom, the first one, the execution event, and it executed several times, made some modifications, renamed some files, but let's go ahead and start with this execution event. Over here on the left-hand side, we can click on this Analyze Event cube. This is for the resolver view. And what it does is it opens up into a tree-like view so that we can see exactly what is happening. From here, we can see that I executed a file called tesla.exe, and it actually created some files, which we are going to dig into this one right here, C, users, packet pub, app data, roaming, and then a file name here. It changed it, and then it also created another file under app data local Microsoft, and we'll see what that is when we get into there. Going down into the tree a little bit, we can see that the running process is Tesla, and it is calling some library files. It terminated a process, but also there was another terminated process which I find interesting, is that it used schedtasks.exe, which is the task scheduler inside of Windows. So again, we can simply click on this, and we can see the process hash and some various other information about it, and we can see that it used schtasks.exe with the /create/tn updates /xml and a temp file. What this is telling us is that the scheduled task.exe program was used with /create to create a scheduled task, /tn to update it, to put it into an updates folder and name it /xml and passed it an XML file, which we saw earlier in one of these 4 files here, this TMP file that is an actually XML file telling it exactly what to put into the scheduled task. So this is extremely helpful for us to look at, and we can see things like the file hash information of tesla.exe. We could see the different information about tesla.exe, but we've got some basic information. So let's go ahead and explore a little more actually on the victim box to see some additional information. So if we hop over to the victim box, first thing we should look at is that the 4 files that were created here. This immediate file creation was users, packet pub, app data, roaming, and then ziypiiyo.exe. So let's go ahead and look and see if we can actually find that file on the box. So first, let's go ahead and open up cmd.exe. And we're in the users packet pub directory, and if we look over here, we can see C users packet pub app data. So let's go ahead and change to that. We can see there's a roaming folder. And now we can look at, do a dir directory listing, and we can see that we do not see our zy file. We see a folder called Adobe, but we don't see the zyipio file. So what we can run is a program called attrib, and it shows all the attributes of the files that are listed. And when we run a trib, we can see there is actually a file here that is zyiplyop.exe. And it has some switches over to the left-hand side of it. SHRI. S means that it has added the system file attribute, meaning that the adversary is attempting to mark this file as being used exclusively by the operating system, so it cannot be modified or deleted. H, it is showing that it is a hidden file. R, saying it is read-only. And I, saying that it will not be content indexed, which means it won't be indexed or searchable by the Windows operating system. So So from here, if we want to do anything with this file, we need to remove the system and the hidden attributes. And we can simply do that using the attrib program again. Using -s and -h. And that removes the system and removes the hidden file attribute. We hit enter. And now we can see that it is in read-only mode and that it is no longer being, it is still not being indexed, but that's okay. Next, before we do anything with this file, let's go ahead and get a SHA-1 file hash so that we can see exactly, to validate when we look at files, when we started modifying them or moving them to when we actually get them off the box for analysis. So some things that we can do is we can use PowerShell to collect that information. And the reason I'm using SHA-1 is because it is a more complex algorithm that can have less chance of having conflicts or collisions. MD5 usually is perfectly fine, but just as a best practice, most practitioners use SHA-1 or SHA-256. So now we see the file hash of this file, and we want to write that down so that when we start copying this file off, we want to validate that once we copy it off to do maybe reverse engineering at the assembly layer or doing debugging on it, that we could actually validate that the file hash that we collected from the box matches the file hash that we have when we actually start doing analysis. So back on this in the resolver view, now that we've actually found the file and we know exactly where it is and we can copy it off to do some further analysis, let's look at this persistence mechanism of scheduled task.exe. Again, we see that it's in scheduled task. It created some sort of recurring program, and it's using an XML file. So back in the box, let's go ahead and see if we can grab this. What you could do is you can use the, just to collect this file, you can use copy zy, and then maybe save it to the desktop so that you can go back and copy it off of the system and again move it off the box and do some further technical analysis. And then you can check the file hash from the source and destination to validate that nothing changed along the way. But let's go ahead and check out this persistence mechanism. We can use scheduled tasks. Opening up Task Scheduler, we can expand the scheduled tasks, and we see Microsoft, which has a whole bunch of the Microsoft scheduled tasks and folder structure that's already in existence. And then we have another folder here called Updates. Click on Updates, we'll see that there is a scheduled task called ZYIPLYOP. It is ready, it has multiple triggers, task is not yet run. If we look down here, we can see some basic information that it runs only when the user is logged on. The triggers are, it's going to run at logon, and that status is enabled. And the actions are that once the scheduled tasks runs, it will execute this ZYIPLYOP.exe file. And so this would be a persistence mechanism that is, again, using a scheduled task that when somebody logs onto the system, it runs this file that was hidden inside of the app data roaming profile or directory every single time that somebody logs in. And this would be a way that that an adversary would be able to maintain persistence, because even though I executed the file in the downloads directory, tesla.exe, and it looks like a Word document, but I executed it as a .exe, and even if I found that and said, oh, that's a virus, I'm going to delete that, this would be a persistence mechanism that every time I logged in, it would fire back up and reinfect the system. So this is a basic way to use a malware execution to identify some files and some systems and processes that are happening by the malware to maintain persistence. However, using the resolver view, we were able to see exactly what persistence mechanisms were being used. and we are also able to see exactly how the programs had executed. Tesla.exe fired off. 4 files were created and then changed by adding the attributes to them, and then another file was created as well. And we can again see all this down into scheduled task on how persistence is being maintained. Now that we've collected some information from our infected host, we can go back into Kibana and perform some additional searches to find out, hey, has anybody else been infected with this? So to showcase this, we'll go into Kibana, click on the hamburger menu, and then go to Discover. And just as an example, we can start off by using the icar file as an example to see how this would work. So we have the file hash that we collected, the SHA-1 file hash. However, I'm using icar just as an example. Icar is a antivirus testing file that always shows up as positive, but it's just a file that we can have a file hash of that we can check to see, did this execute on this host at some point? And the answer is obviously yes. What we can show is we can show some different fields that we can add so that we can really highlight the information that we can see. So let's start with hostname. So I want to see the hostname that had this file execute on it. And let's look at the MD5 hash, and we can see that as well. And then we can even look at the SHA-256 hash as well. So this is just showcasing very, very simply a file executed, and we were able to do a search based on the file hash onto a box to find out, has anybody else had this file execute or observed on its system. So let's go ahead and go on to what we actually observed with our system. So let's get rid of this search criteria. Just hit the new button here. And it jumps to my default index. We're going to hop over to WinLogB to start with. And let's go ahead and look at any files that were created. We're looking at the file directory of C users packet pub app data roaming as the directory, and any files that were created inside of there. And we can see 4 events in which that did occur. From here, we can add some additional information so that we can see exactly what was created. So again, just like before, we added the file hash, we can add the host name. We can add the directory. We can add the file name and the event type. Granted, there is a tremendous amount, as you can look here, there's a tremendous amount of information that you can add. I'm just adding some for column names just as an example. We can see this is the file that we've been tracking, and it was executed several times on the box while we were doing some testing and data generation. Next, let's look at, this is interesting information for WinLog, but let's see what the detection engine has told us, or the endpoint agent. So let's remove this information. Let's click new here, get rid of all the column headings. And we'll go over to the logs index pattern. And from here, instead of doing an actual search, which we can do it that way, let's go ahead and just create a filter, and so we can explore the data a little bit this way. So let's look at any network data. So we've identified the file hash and some directories that it could be located in. Let's look at some endpoint data or some network data as well. And that is in the event.category, and we'll just select these drop downs, is network. So now we're seeing all of the network events that happened on this system over the last year. I'm going to add the process executables that we're going to track specifically so that we can see what network events were actually done by this, this file that we're tracking. And if I start typing, as you can see, it populates with all the different options that I can select. But right here we have zyiplyop.exe. And save. From here, we can see that while we were doing data generation and collection, this executed several times. And so now we're looking at just network data that is being generated by this host, by this executable. So again, let's add some columns. Let's look at the DNS questions and answers. So that's all interesting information. We have an IP address here. That's a great indicator that we can search for. A domain, again, great indicator that we can do some searching for. And just to make sure we can see exactly what was the process executable. So again, we know that this is the executable that we're tracking, and we can see some good indicators on the network side that we can look for as well. Let's add the destination ports. And of note, we can see we're looking at DNS questions, but we also see some traffic going to a port 587. So that is an abnormal port for normal web traffic. So this is something that I think that we could search for. We can't see it in the endpoint. However, we have PacketBeat data that we can go and look and see, does PacketBeat know anything about traffic going to port 587? So again, we can just hit the new button here, and we actually fly over to PacketBeat. It's my default index pattern. So let's go ahead and search up here for destination .587, and we do see a lot of traffic going to there. So host. And let's see what the type of traffic this is. If we scroll down and click, so it's IPv4. And it is going to the same IP address that we were tracking here, 198.54.114.191. We can add this as a column as well. The event.dataset is flow, so that means that PacketBeat doesn't have a protocol analyzer for specifically whatever this was, but we do know that it's IPv4, it's over TCP, and that it sent 490 bytes. So this is something that, again, we could look for. Hey, has anybody else gone to destination port 587? And we have, again, just our system, and this is just the IP address that it went to. So again, we're narrowing in on all of the events that happened from that infected host, from that piece of malware, and all the network connections that were made from that box, from that actual executable. And from this, you can generate additional searches. Again, back in WinLogBeat, looking at, do we have the ability to create a really good query so that we can make this into, again, look at any other infected host that we may have. So let's go ahead and hit new here. Go to WinLogBeat. And we're going to want to show, we're going to do a pretty big query here. And so we're going to say, I want to see anytime the process name of scheduled task, schtask.exe, has the following process arguments, /create and /tn and update and /xml, and XML being fed from app data local temp star, whatever this number happens to be, .tmp, and the process parent executable is in the user's app data roaming directory and is in a .exe file. If we click update, we see that we have 7 events that happen. So this means that the initial infection happened, and we can even see here that every time that the infection fired off through different data generations and whatnot, TMP 6727.tmp, TMP 8578, 43888. Every time it's a different temp file name. So this search looking for TMP star.tmp is going to catch those sort of things. And then now we have a search that we can again look for hosts that could be infected. Again, it's all us, our same victim machine, but you would see different host names here if this had spread laterally throughout your environment. And then we can also take this and to create customized detection logic so that this fires off every single time that it happens instead of us having to go back and do searches for it. Now that we've identified the infection and gotten onto the box and pulled it off, and identified some ways to search through our data to identify potentially other malicious files or infected hosts, let's create some detection logic so that we aren't continually having to go search through this. So if we are inside of Kibana, we can click on the hamburger menu and then scroll down to detections under security and manage detection rules. And let's create a new rule. So we're going to create a custom query. As we saw before, our index patterns can either be win, log, beat, or logs, which is provided by the endpoint. So when and we'll just go ahead and paste in the search that we created earlier. And we should know that this is probably a little bit noisy. Basically, it's going to be every time that scheduled task is used to create a process with these parameters. We know that this is potentially malicious, so it would be something that we would want to look at because we've absolutely observed this persistence mechanism specifically for this malware infection. So while it may warn us that this is a little noisy, I think we can say that we are confident that because we saw it, we're creating the detection logic for it. We can click the preview results button. We can see that we have definitely identified 4 processes in which this has happened. This has run a couple times since the machine has been rebooted. Pressing continue, we can say, give it a name of we can mark the severity, let's say medium, and we can tag it, let's say tag as Packt pub. Advanced settings, any reference URLs that we have, which we don't. False positive examples, which we don't want to necessarily call out here because we're not sure. Let's also tag this as Tesla. And we do want to select on the MITRE attack tactic, and we want to start with, as we talked about, this is a persistence mechanism, and then we want to add a technique, and the technique is scheduled tasks. And then we can even add a sub-technique here of actually this is a scheduled task as opposed to a cron job or something similar. We could fill out the investigation guide. Author is Packt pub. We want to schedule this rule to run every 5 minutes. I usually bump this up to 9 minutes, but that's just the way I've done it for a long time. So 5 minutes may be fine if that's how often you want to run it. With a 1 minute look back. And then we don't have any actions to perform, but we can create the rule without activating it or create the rule and activate it. And so we have now created a custom detection logic specifically for the Tesla agent persistence mechanism that we have observed. And this would run next time, and then when the machine reboots again, it would fire off and this alert would catch that in the detections window here.